Welcome to EDU World Space.
All right, we're going to try to calculate or prove this inequality that you see right here. What's important is that the book specifically asks you to do it without evaluating the integral. So how do we approach this? We use one of the properties of integrals that says if you have the same limit of integration, and if you have an expression that's less than the other function, then the integration is also going to be less than it. So long story short, we are going to prove that this portion is larger than that portion, and that doesn't involve the evaluation of these integrals, so we're going to be able to do that. Okay, so let's compare the square root of 1 plus x squared versus square root of 1 plus x. We know that square root functions are 1 to 1, so we know that the input is what really matters here to decide which one's larger. So I'm going to look at x squared versus x. I am going to ignore the 1 because 1 is just added to both of them. So if I subtract it from 1, you can subtract it for the other, and then the relationship between which one's larger and which one's smaller doesn't change. Okay? Now, x squared versus x. Just by looking at it, you might think that x squared could be larger than x, but that's not necessarily true because in this case, we're looking at the region 0 to 1. Okay? Graphically, what's happening is this. X squared looks like this, while x looks like that between the region 0 to 1. So eventually x squared is going to be larger than x, but when x is a number between 0 to 1, we know that x is actually larger than x squared. So what's the relationship that we see right here? X squared is less than x, and going back, we can show that the square root of 1 plus x squared is less than the square root of 1 plus x. And according to the properties of integrals, this is also going to be true. Now, what's important is the fact that it's from 0 to 1, okay? Without this, we're not able to prove this portion, so it wouldn't work. So keeping that in mind, we were able to prove this situation.